So in this video, we're going to talk about the basics of something called dimensional analysis, which is a process we're going to use throughout the year. And this will cover basically everything on page 14. And you should make sure that you have a calculator to use. Now in class, we're going to use that one specific calculator that we have by the door unless you bring your own calculator back and forth. So it is going to be important that you practice this on one of my calculators, but even if it's your phone calculator or a computer calculator, go ahead and pull that up and have that ready, because it's going to be important that you can practice doing these calculations even when I set them up for you, because half the battle is taking the work, the equations, and the numbers that we set up where they are, and getting the calculator to do the right things with them, and that involves some skill on your part. So we're going to practice both of those things, setting up and doing the dimensional analysis part on paper, and then putting that information in the calculator and getting the right answer out of it. So, without further ado, let's jump right on in. At the top of the page, on page 14, of course, the first thing that we need to write down is a definition for conversion factors, because that's what we're doing with this dimensional analysis stuff, is converting between different units and getting new numbers for these quantities in these new units. And these conversion factors that we're going to be using are really just a fraction form of a unit equation. And so that purple definition there is really all that you need to write down until we get to that next slide, where we'll fill in the next blank. But while this definition is nice and short and simple, if you don't know what I mean by a unit equation, then it's not really that useful. So I am going to talk about a couple more things here on this page that you don't necessarily have to write down, but it'll help you understand this conversion factor regardless. So what do I mean by unit equation? Well, a unit equation is a statement of two equivalent quantities with different units. So the example I have here, 2.54 centimeters equals 1 inch. Those two things on either side of my equal sign are equivalent. They're equal to each other. 2.54 centimeters is the same as 1 inch. It's just different units for the same measurement. Now, we are going to be using these unit equations in dimensional analysis, and all we're really going to do is rearrange them to turn them into this unit equation. We're going to take those two sides, the stuff on either side of that equal sign, and put one side over the other side to turn it into the fraction form of a unit equation, like what we set up top. That's our conversion factors. Now, keep in mind, because we have two sides to the equation, every unit equation can be turned into two different conversion factors, just depending on which side you choose to put on top. So here you can see that example unit equation that we wrote down before turned into two different conversion factors, just based off of whether the centimeters part was on top or on bottom. And depending on what problem we're solving, we might want to use one of these conversion factors over another, and we'll always have to make that choice. But it's a simple change to take a unit equation and turn it into a conversion factor. We're just taking either side, putting one over the other with a line in between. Do notice here that units are always included in these conversion factors, as well as, of course, in our unit equations. It would make no sense at all for me to say 2.54 equals 1 inch, because it doesn't. But 2.54 centimeters does equal 1 inch. So those units give these numbers meaning, and a lot of what we do is going to be focused on getting a number out as an answer, but realize that the units are going to be what gets us there, and the units give all of these numbers meaning, and you're not going to get very much credit for these problems if you don't include units. So every single number on this page needs a unit after it, some kind of letter, symbol, something to tell us what that number means. Now, the next thing we need to fill in here is, okay, we're going to be converting stuff with these conversion factors. And when we're putting together these conversion factors, we're going to be canceling units. And it seems a little weird, but I'll explain more as this video goes on. And if we're trying to cancel a unit, we always need to place it on the opposite side of the conversion factor from where we already had that unit. And that's going to help us cancel out and convert the units we got into the units that we want. Now, for the most part, when I say the unit to be canceled is placed on the opposite side, most of the time for us, the opposite side is going to be the bottom side of this dimensional analysis process. So cancel it by putting it on the bottom. So a lot of these brackets, this work, we're going to kind of build from the bottom up. Now, thinking about canceling, this is going to end up being a whole lot like canceling things out in math. If we had an equation, just something simple like 3x equals 6, and I was trying to solve for x, well, I'd have to get rid of the 3. I'd have to cancel out that 3 in order to get rid of it. And how would I cancel out my 3? Well, hopefully you'd be telling me to divide by 3. And look at what you just did there. Because I had a 3 on the top in this equation, I put a 3 on the bottom here to cancel it out. That multiplication and division are opposites, and by doing this, we've canceled out 3. But even if I had this look a little different, let's say that this was 1/3 x. Well, if I'm trying to cancel out 1/3 x equals 6, then we would be multiplying by 3. Really multiplying, like that's technically a fraction. The 3 is on top of this fraction that we're multiplying by because we already had a 3 on the bottom. So putting that 3 on the top, multiplying by 3, canceled it out and gets rid of that 3. Now, I know I would also have to do the same thing on this side, and we would have to go through a little bit more of a process in order to actually finish solving that equation. But just that first moment when you're asking yourself, how do I cancel this? It's going to get canceled by being put on the opposite side. The biggest difference between that, well, there's going to be a lot of differences, but the biggest one is generally that we're actually going to be canceling units, not numbers. But the same idea is still true. Opposite side is where we can cancel stuff from. So this next slide, you don't have anything to actually write down. This is just for me to tell you why you're going to be seeing some weird letters down the side of my page, because I'm going to be solving problems using what's called the guess method. And the guess method starts with a G for given, where you look at the problem, you find what information you were given. It's usually part of the question, as weird as that might sound. If they tell you, like, how many apples can I trade for 10 oranges? Your given is the 10 oranges. It's part of the question. You got to know what we're going to be turning into those apples. So given is what you've got. The unknown is also part of the question. It's what the problem is asking for. So in this case, if I was asking how many apples, apples is my unknown. My given was those 10 oranges. I'm sorry, I probably flipped that up. Again, it's just a simple example that I use over and over again. The E step is really where you start doing work to help make your life a little easier down the road. The E step, E stands for equation. And this is where we're going to actually write out some unit equations that's going to help us get the conversion factors we need, because all we got to do, just like what you saw me do on the last slide, is to get a unit equation into a conversion factor is decide which part goes on top and which part goes on bottom. So writing those equations is going to be really helpful. It's not required, though. You don't have to, but I really think it helps with the dimensional analysis process. And then those two S's at the end of our method, the first one stands for substitution. That's where we put all of those numbers and equations together into the conversion factors and actually set up the dimensional analysis. And then, of course, solve or solution is for the answer to the problem. So I'm going to use these to organize my work as I am writing things out. And like you see on this next problem, you mostly are going to see ESS, because I'm going to kind of highlight and underline and get the given and the unknown by reading and writing all over the question itself in the problem. And then I'm going to actually just make sure to devote some space to writing those equations, getting it ready, and then doing the substituting and the solving. And just FYI, the only thing you need to do that's required is the substitute and solve. I don't actually need to see the equations. You don't have to write ESS anywhere, but if it helps you devote some space and some time to those parts of the process, it might help your process turn out better. So I am about to work out this example problem, and if you're looking frantically up and down on page 14 saying, I don't have a problem about M&Ms, where is this, what's going on? Well, the answer is it's not on there. This is a problem that I worked for everyone before they started writing anything on their paper, because I wanted you to see exactly what you were going to be doing to understand this whole process before you're worried about writing down every single thing that I've got. So I'd recommend or request that you do the same thing, even if you're listening at home to this example on your own. I know you could copy this down if you really, really, really want to. If you think it's that great of an example, do it after listening to this the first time. I want you to just watch this process happen for the first time right here on the screen without writing a single thing, just following through, not pushing pause and waiting to write stuff down or to go back or anything. Just watch this example, and then if you want to write it down, sure, go back, click through, copy it down, or just skip it completely. You do not have to write this anywhere. I just want you to see kind of the grand scheme of what we're going to be doing here. So this question is asking us how many M&Ms we would burn off while running a full marathon, which is evidently 26.2 miles. It's known an average person burns 310 calories for every 3 miles they run, and there are 140 calories in one serving of M&Ms, which is 32 pieces. So lots of stuff in there, but if we focus on the question, which is actually at the very beginning of this, how many M&Ms would I burn off while running a full marathon? Then what I'm looking for, my unknown is M&Ms, and my given is the 26.2 miles. Evidently, I am running a marathon. That's what's given. That's what I've got in front of me. And what I need to figure out is how many M&Ms I'll deserve at the end, or how many I will burn off from already having eaten while running this marathon. So my job is to get from miles to M&Ms, and that's my given and my unknown. Everything else in this problem, as much as it might seem like there was a number given to me, these are really some kind of sort of sneaky equations that are written out in word form, and we can turn those into some unit equations just by taking out the extra words. Here where it says that the average person burns 310 calories for every 3 miles, then for the average person, 310 calories equals 3 miles of running. And when we say there's 140 calories in a serving of M&Ms, which is 32 pieces, then we can say 140 calories equals 32 M&Ms. And that way we can just be focused on the numbers and their units and how they fit together into these unit equations. So simple equations just kind of pulled out of those words. So, done with my E step. Let's start setting up some dimensional analysis. In general, I draw a big long line to start things off because like we talked about before, we're going to be putting stuff on top of and underneath to cancel things out and get the units that we want out of the end. You don't have to start with a super long line. Some people kind of prefer, especially if they write in pen, which I don't really enjoy, but it happens. They just draw the line as they need to, and then they can make it longer as we add more conversion factors and keep moving forward, and so that way they just use the space that they've got and that they need. It's up to you once you start writing it out. But for here, because this is my way, I like to start with the line already drawn, and I'm going to put all my numbers and units on this line someplace. And the first number that always goes on our line is the given. So here my given was 26.2 miles. So I write that number and its unit there on my line. And at this point, that's what I've got. And my job is to use those equations, the unit equations, to convert these miles into M&Ms like the question asked for. But which equation should we be using to help get rid of these miles? We don't have much other guidance, but if we look at the units we've got, miles, I need something that's going to help me cancel out those miles. One of my 2 equations has miles in it, and thus I could use it to help cancel out these miles that I've got. And hopefully you're looking and realizing it's the green equation. That's the one with the miles in it, so that's the one that's going to be helpful to us for canceling out the miles that we've got and moving a little bit closer towards M&Ms. So remember that this green equation can be turned into conversion factors in either of 2 ways. The one with the calories on top or the calories on bottom, the first or the second option that I have written here. Same equation, base, we've just turned it into these 2 different conversion factors. And we should be asking ourselves, which of these conversion factors is going to help me cancel my miles? Well, the way I cancel things is by putting them on the opposite side. So if my miles are on top, I need the conversion factor that has the miles on bottom to cancel out the miles I've already got on top. So that's going to be this first conversion factor here. And we're just going to write that right on our line with the 310 calories on top of the line and the 3 miles underneath it. Notice when I add a conversion factor, I kind of separate it from the numbers, the given that I already have with a vertical line, just to kind of keep it separate and give it some space. So if I stopped and calculated now, my miles have canceled each other out. The numbers are still there, but notice my miles and my miles match on this diagonal. This is what I call the diagonal rule, is every single unit on these diagonals in a problem, this dimensional analysis process, should match each other because that's how we're canceling them. So what I've got left right now after my miles cancel each other is calories. And so if we stopped and calculated now, this would tell me how many calories I burned by running a marathon, but I don't care about calories. I care about M&Ms. So we still want to cancel these calories, and the way that we're going to do that is by using the blue equation, because we've already used the green one. That one is just going to take us backwards if we tried to use that again. So each equation only gets used once, and if we keep using them, they'll get us to our answer. So we have 2 options with the blue equation and 2 conversion factors we could make from it. And if we want to choose one or write one that's going to help us cancel our calories and get to M&Ms, then hopefully you're seeing that the second one is going to be the one that's useful now because it has calories on the bottom. So when we write that here in our dimensional analysis bracket, the calories and calories cancel, and what I'm left with is M&Ms. So at this point, because my diagonals match all the way from my given to that last conversion factor, miles, miles, calories, calories, and all that's left up on top at the end is the units, this thing that I wanted to end up with, then I can be confident that I am done setting up my dimensional analysis and it's time to actually calculate the answer. So I'm ready to pull out my calculator, and hopefully you are as well. Once you get all of the numbers and units where they belong on this line, then what we do is we multiply together the numbers that are on the top, and we divide by the numbers that are underneath. And so in your calculator of choice, I'd like you to type in 26.2 times 310 times 32, and then divided by 3 and divided by 140. Now, I do feel fairly strongly about doing all of this all at once in the calculator and just pushing enter at the end, because that's going to help me fix things. If you don't end up getting 618.819047, then you did something wrong with how you were plugging that into the calculator. And I want to help you understand what went wrong. It could just be a typo in the calculator. It could be a button not registering, or it could be that you're just not using the calculator right, and I want to help you fix it. So, as simple as it might seem, go ahead and try plugging this into the calculator that you got. If you're not getting 618.819047, let me know, and I'd like to help you fix it and figure out what's going wrong there. Because if, like I said earlier, if you can't actually take a problem I've set up perfectly and get the correct answer out of it, what hope do you have to get your own answers correct if you're setting them up yourself? Because there's no way it's going to turn out right. So that is the process that we go through, and we got a number answer out now, but it's still not quite finished. There's 2 things really wrong with this answer. First, of course, units. We're going to put M&Ms on this answer, but the second thing is sig figs. And even though we have all of these different numbers that are combining together into this answer, the only ones that matter, the only ones that determine how many sig figs I need in my final answer is the given. So because 26.2 has 3 significant figures, then my answer needs to get rounded so that it has 3 significant figures. So we keep the first 3 digits, look at that 4th digit to round up the 3rd digit that I've got, and hopefully you'll agree that our final answer here is 619 M&Ms. That's how many M&Ms I would burn off while running a full marathon. So this is our process, and it's really, really important that you try this setup part of things, even if you're going to struggle with it on your own at first, but come with questions if you're not understanding it. Show me the work that you've got, even if it's horrible and it's giving you the wrong answer. Seeing where you're making mistakes in these types of problems is key to me helping you fix it. So just a quick note before we move into some real examples. When we grade this on your test, your final answer here is worth 2 points. 1 for sig figs and rounding, 1 for just being the correct answer, and 1 point for those units being on there. But every single conversion factor here is going to be worth a point as well. So out of this 2, 4, 5, 8-point problem here, you'd only get 3 points if you were able to look at the problem and without any of this setup say, oh, that'd be 619. It's impressive. I understand you've got some skills that might be better than some of my skills, and that's fine. But the important thing here isn't really the answer, it's the process. This process, this dimensional analysis stuff that we're doing here is going to be a process that we learn and that chemists use to solve all different types of problems without being given an equation. So this is a problem-solving process that we're going to use from Unit 1 through Unit 12 in May when we're completely done. And once we get to the spring, Unit 7 through 12, every single unit has some of this built into it. So we need to learn the process. It's about how we set things up, organize our units and our numbers to get the answer. It's not just about doing this red calculation stuff here at the bottom and being able to get this answer. No matter how much of this work you show, you're not getting any credit for it. This would still just be 3 points if you did not show the dimensional analysis. So keep that in mind as we start to work these problems on your packet page. You could probably look at this page and figure out most of these answers. And if you want to double check yourself, you can. But the real thing I'm trying to teach you here isn't how many horses I could exchange for 1,500 chickens. It's how to get to an answer like that when all you've got are some random equations and facts thrown at you. So let's go ahead and work this first word problem, dimensional analysis problem out together. So evidently, before the use of money, people bartered for goods they needed. If 25 chickens could be traded for 1 pig, 10 pigs could be traded for 1 cow, and 2 cows traded for 3 horses, how many horses could be exchanged for 1,500 chickens? So if my first goal in this guess method is to find my given and my unknown, I'm going to focus on the question, which now is at the end with the question mark. How many horses could be exchanged for 1,500 chickens? So my given here is 1,500 chickens. That's what I've got. And I don't really want chickens. I want horses. So I want to figure out how many horses could be exchanged for this 1,500 chickens. Now, as you're starting to think how crazy 1,500 chickens are, firstly, they're small, so we can have lots of them. Secondly, I'm not 100% sure I have exactly 1,500 chickens with 1,500 written like this. This is about 1,500 chickens. If I was sure I had exactly 1,500 chickens, not one more, not one less, I would put a decimal point here. But without that decimal, remember, the 1 or 2 sig figs, really in our brain we should be saying about. So I didn't get up this morning and count every single one of my chickens, but I knew last week I had about 1,400, maybe close to 1,500, so I probably have about 1,500 chickens. And I just want to figure out how many horses I could get if I wanted to get rid of all these chickens. And unfortunately, there's no one just trading horses for chickens, so I don't have a clear answer for that. So maybe this problem is me trying to figure out how many horses could I get? Is it enough to kind of make it worthwhile to wrangle all my chickens together and bring them to the market? Because if it's not going to get me enough horses, maybe it's not going to be worth it to get all those chickens down there. So that's my given and my unknown. And all the rest of these equations that we have here, with a lot of words written in between, I am going to go ahead and write out for you here. I've got plenty of space to do that, although I am going to abbreviate chickens just to make it a little bit shorter. If you don't have the space to write these equations in your page, because I know you don't have as much space as I do here, you don't have to. Remember, the equations are not required, but they do help as you're trying to turn things into conversion factors. So I'm going to write them out here, and you can use them to just show your work and your answer eventually. But if you find them useful, go ahead and pull out an extra sheet of paper. Feel free to take as much space as you need, and you can just staple that to the back of the packet. You don't have to rework things. So I got my first equation there, and then 10 pigs can be traded for 1 cow. So 10 pigs equals 1 cow. And finally, 2 cows can be traded for 3 horses. So 2 cows equals 3 horses. And that seems like all the information that I was given in my problem. So I'm hoping this is enough to get me to my answer. But let's go ahead and start doing some dimensional analysis. I'm drawing my line, and the first number, the first thing we always write on our line is our given. So here we're going to write that 1,500 chickens, and I am going to keep with my abbreviation for chickens. When we have some more sciencey units like meters and moles and atoms and molecules, we'll have some more official abbreviations, but feel free to just use CH perhaps, because cows is also going to be C. So CH, CO, P, H, that works fine for me here at this point. So if we've got chickens and we don't want this many stupid chickens, I want to get rid of these chickens and try and get my horses, then I need to look at my equations and ask myself, well, which equation is going to help me cancel out these chickens? And hopefully you notice that these chickens are right there at the beginning of my purple equation. So we need to write that part of my equation on the bottom side of this conversion factor to cancel out the chickens we had with these chickens from the purple equation. My first trade is going to be chickens for pigs. And remember with these conversion factors that the equations stay together. The only thing we're deciding when we take this purple equation and put it in this first space of my dimensional analysis is which side goes on top or on bottom. They still have to stay connected. They still have to stay on top of each other. We just need to decide which part needs to be on bottom so that we can keep canceling out the chickens that we don't want. So I got rid of chickens. I've used my purple equation, and now if I stopped here, this would tell me how many pigs I could get. But I don't want any stinking pigs. So let's get rid of these pigs. Let's cancel them out and look at our other equations. Which equation could possibly help us cancel out our pigs? Well, it's going to be our green equation. So we're going to take those pigs just like the chickens that we had. And those pigs are going down onto the bottom of this next bracket. 10 pigs on the bottom, and that means that the other part of that equation is filling in the top. So here my chickens and my pigs have now been traded away, canceled out. And if I stopped now, this would tell me how many cows I could get for all of those chickens. But I don't want cows. I want horses. And we only have one more equation to use, so hopefully that's enough to get us there. If we want to cancel out the cows we got, then we need to put the 2 cows on bottom and 3 horses fill in the top. And I'm still checking diagonals, not really crossing them out. We still need to be able to see these. That's why I'm using my highlighter tool here. But I've got all my equations used. If I'm not sure if I'm really done or if I should bother putting this in the calculator, if maybe I did something wrong, check your diagonals. Chickens, chickens, pigs, pigs, cows, cows. All my diagonals match, and the units that I was looking for, horses, are sitting here at the end up on top. So this looks like I've set this up right, so it's worth stopping and putting this into our calculator. And if you need some assistance, this is definitely not needed to be written out formally like this, but I just want to make sure we don't miss anything. Is start with your given number, type that in, and then you can multiply all of the numbers across the top, and then push divide before any of our numbers that are on the bottom. And once you get all of those in, then you can push enter, and hopefully your calculator is telling you that's a pretty reasonable number of horses, 9 horses. If you're not getting 9, double check what you're typing in and making sure that you've got all of those things and you're not accidentally forgetting like a 0 here and just dividing by 1 instead of 10. But if you're not able to figure out what went wrong and how you were putting this in your calculator, please, like I said before, ask me for help. I want to help you get there. So 9 came out of our calculator, but that's not our final answer. Let's fix the sig figs first. Looking back at our original number, we only had 2 sig figs here, and I pointed that out before, that it's 2 sig figs, not 4. If we had a decimal, if I counted every single chicken, then I would have 4 sig figs worth of chickens. But since I only counted about 1,500, that's only 2 sig figs, so I can only keep 2 sig figs in my final answer. But we only have a 9 here. That's only 1 sig fig. So we need to add another significant figure here. And without changing the value, the only one we can add is a 0. So 9.0. I know I have exactly enough chickens, if I've got exactly 1,500, to trade for exactly 9 cows. So I guess, 9 cows. I guess I need a unit on this, because I very nearly said cows, and I don't want cows. I wanted horses, and that is what this should have calculated. So 9 horses. So I guess what this is telling me is if I want to make sure that I have 9 horses when I'm leaving the market, I should maybe make sure I have exactly 1,500 chickens, because this is going to turn out to be pretty much equal to what I'm needing there. So, hopefully this process isn't too bad or too scary for you. It's really just about paying attention to these units, making sure we got the units organized on these diagonals, and canceling out what we don't want to get what we do. So let's do another problem. And I'm going to stop before I finish setting this one up completely. And I did the same thing in class. I just want to see what you can do on your own. So if you don't get the answer that I tell you for this one, come in, let me help you with this. This isn't something I really like for you to learn through a video. That's the whole reason these were live notes and why this video is so incredibly long right now. But a lot of the rest of this page is going to go pretty quick. So let's focus on this one last kind of longer problem before we move on. Here, a car enthusiast developed a system for placing values on cars. In their system, 1 Maserati is worth 3.5 Porsches, 1 Porsche is worth 5 Jeep Wranglers, and 2 Jeep Wranglers are worth 15 Ford Pintos. If we collect 225 Ford Pintos, how many Maseratis would they be worth? So I kind of made some notes on this as I was reading through it. I know my given, what I've got is 225 Ford Pintos, and I want to try and turn those Ford Pintos into Maseratis. And we have a few equations here that are going to help us do that. Now, I am going to abbreviate these car names a whole lot just because I write really big. So I'm going to say 1M for 1 Maserati is equal to 3.5 Porsches by saying 3.5 P. And then 1 Porsche is equal to 5 Jeep Wranglers. And then 2 Jeep Wranglers equals 15 Ford Pintos. Okay, so that's all of the information from our problem. So hopefully that's enough for us to set up and solve this next dimensional analysis structure. And remember that we always start with our given. So that's about as far as I'm going to be going. 225 Ford Pintos, which I am going to abbreviate FP, just like what I did up there in my equations. And at this point, I'd like you to try and finish this out. See if you can get to an answer. I will let you know that this answer should be between 1 and 5. So we're not going to have very many Maseratis, even if we do trade in all of our Ford Pintos. And I will point out that if we have such a small number of Maseratis as our answer, but I'm starting with this big 225, which is 3 significant figures, then we're probably going to end up keeping some decimals in the number of Maseratis that these Ford Pintos would be able to be traded for. And I know it might hurt your heart to write out or think about fractions of a Maserati, something 0.5 Maseratis. Oh my gosh, no. But I promise you, no one's going to be out there taking a chainsaw to any Maseratis. We're not actually going to cut them into pieces to make this trade. It's just telling us what this is worth. So if I have something 0.5 Maseratis and I really wanted just one more than what I could afford or trade them for, that tells me I need to save up some more Ford Pintos before I can trade them in for as many Maseratis as I'm expecting. If I'm happy with rounding that number down, even if it's a decimal, rounding it down and having the number of Maseratis I can as whole Maseratis, then maybe I'll have some Ford Pintos left over. So keep in mind that even when it seems weird to have a decimal number like Maseratis, like, no, please, I don't want a fraction of a Maserati. You're right, you don't. But knowing this information will help you make decisions later. So we are going to stick with our 3 sig fig answer, even if it hurts a little bit to write it down. And if you're not getting an answer between 1 and 5, once again, you probably set it up wrong or calculated it wrong. And the thing that I've seen people do most in class is assume that I'm going to start with the purple equation here. And my one hint to you is you're not. My, secondary hint to you with this is to remind you to check your units on the diagonal. We can't use the purple equation here because M and P are not the same thing as FP. Maseratis and Porsches are not the same thing as my Ford Pintos. So remember, I don't want my given. I don't want these Ford Pintos. So I need you to help me cancel out these Ford Pintos, get rid of them, and get me closer to Maseratis. And it might take a couple of steps before we end up with Maseratis on this line, but once we get there, it'll be worth it. So now that you've done number 2, hopefully you feel pretty confident in it. Even if you don't, I'd like you to try to look at 3, 4, and 5 on your own. 3 and 4 are both pretty straightforward. There's like 2 equations, maybe even just 1 in number 4. So they are going to be shorter than what you just did in 1 and 2. 5 you might need a little bit of help with. I am going to go ahead and work them out on the next couple of slides. And I'm mostly going to just kind of show you the process that we go through to solve it. But while you're trying these, I want you to try them on your own, because if you can get them, then you can skip this next bit of the video. Just come back to do 6 and 7 with me, because I promise you, no one so far has, in all my years of teaching, has managed to just look at 6 and 7 and get those on their own. So make sure you check back in with me, finish 6 and 7, even if 3, 4, and 5 are done easy peasy on your own. And a quick note about 3, if you hadn't already done this with the note that I have on the screen, go find the given in number 3. The 500 grams that we're going to try and turn into ounces, and put a decimal at the end of that number. I want that to be a 3 sig fig 500 grams instead of a 1 sig fig 500 grams. Number's the same, but I want your answer to be 3 sig fig, so that's why we're going to sneak that little decimal in there. So hopefully you remember to put this little decimal in number 3. If you already got the answer that I showed you, you can probably skip this part if you have not already figured that out, then I'm here to help. So like I was already pointing out on the previous slide, I've got 500 grams and I want to convert that into ounces. So ounces is my unknown, my given is this 500 grams. And then it's pretty nice, it kind of spells out our equations for us. So 1 pound equals 454 grams. I guess I might as well write that out for us. And then 16 ounces equals 1 pound. I am going to go ahead and abbreviate ounces as OZ. No, I changed my mind. This will be short enough. We can do that. So 16 ounces equals 1 pound. So it's pretty straightforward. Our given here is going to be that 500 grams. And I am going to make sure to put my decimal here too, because it'd be easy to forget that that's a 3 sig fig given if I don't include that. And here, if I've got grams as my given, then I need to use my purple equation next as my next conversion factor, because it's the one that has the grams in it. And I'm going to make sure, since grams were on top, that I put that 454 grams on bottom, and then 1 pound can fill in the top. Then is going to need to be my blue equation to turn these pounds into ounces. The diagonal rule tells me that the pound part should be on bottom, which means that those 16 ounces can fill in the top. If I'm unsure if it really is that easy, we check our diagonals. Grams matches with grams, pounds cancel with pounds. What I'm left with up on top at the end is ounces, and that is what I wanted to end up with. So we're ready to calculate this and put it in our calculators. And if we put this all in and multiply all these numbers across the top and divide across the bottom, then our calculator is going to tell us this is 17.621145, and it keeps going on and on. But looking back at our given, which we made sure had 3 sig figs, then I will only want to keep the first 3 sig figs from my answer. So 17.6 ounces is our unit, and this is our final full credit answer. In the next example, we're given 2.33 moles of water. This is something we're going to talk and work with a whole lot more this year. And for water, 1 mole is equal to 18.02 grams. So this is our equation. This is our given. And all we need to do is figure out how many grams there are with this many moles. So that should be all that we need here. So if we start our line and put our given on it, of course, 2.33 mole, then I need to ask myself, what part of this one singular equation do I need in order to cancel out the moles that we've got? Oh, and side note, I know that I left off ES here. Technically, this is the standard abbreviation for moles. M is taken by meters, MO is months, so MOL is as short as we can abbreviate this word, and it's already pretty short, but that's kind of just habit for me. So if we've got moles on top, then we need to cancel them out, get our grams by putting the 1 mole on bottom, and then that 18.02 grams can go on top. And that's it. That's all we got to do. So I just need to do 2.33 times 18.02, which my calculator tells me is 41.9866. And looking back at our given, 3 sig figs here means I just want to keep these 3 sig figs, but we have to round it to 3 sig figs. So the 8 still gets a say in things, and it's going to round the 9 up. And that means that the 9 is going to round the 1 up. And I know that this can get a little bit weird and confusing, but keep in mind, we still need 3 sig figs. So if we just rounded this up to 42, that's 2 sig figs. So we need to add back in that 0 there. The 9 basically turns into that 0 as it rounds up the 1 that's next to it. So that rounding kind of carried through, but it only did that because this last number was a 9. So 42.0 grams, of course, is our final correct answer. Question number 5 here is where we finally see a question that's a little bit more realistic in terms of the long-term dimensional analysis we're going to do. We're not always going to have the question tell you exactly what equation to use. Part of this process is going to be thinking about what equations, what do I know about these units? What equations could I use that's going to help me do this conversion? And then you have your equations and use them as conversion factors. And this is the first time you're really seeing this happen. This question is asking us to calculate how many seconds there are in 24 hours. And once again, I'm sure some of you could probably do this without dimensional analysis. So I want you to try practicing setting up that same problem in dimensional analysis form and seeing if you can get that same answer. So if I'm trying to turn this 24 hours, which is my given, into seconds, hopefully I know something about hours and seconds. And while I don't off the top of my head know how many seconds there are in 1 hour, there are a couple of things I do know and can count on. 1 hour is 60 minutes. Hopefully that is pretty automatic to most of us. And you do need to remember that in general. So that would be helpful if we wanted to know how many minutes there are in 24 hours, but that's not what we want. We want seconds, but at least minutes are a little closer to seconds than hours were. Do we know anything about minutes and seconds? Well, sure. 1 minute, just like 1 hour is 60 minutes, 1 minute is 60 seconds. So here I can kind of start to visualize my plan. I'm starting with hours. That's going to be my given. And this conversion will help me get hours to minutes and then those minutes into seconds. And so this is kind of my plan. By writing out these equations, I can make sure I'm connecting the dots, connecting my given with my unknown, and I have a plan of attack, a plan to get one into the other. So I think this is all that we're going to need. Let's go ahead and see if we've got what we need to get there. 24 hours is our given. And then if this is hours here, let's go ahead and try and cancel out the hours by putting 1 hour on bottom. 60 minutes thus gets filled in for the top. My hours match up. Diagonal rule is good, so I'm ready to move on. Haven't made any mistakes yet. Now that I have minutes here, I'm going to take the minutes part of my next equation. 1 minute goes on bottom, and then 60 seconds goes on top. Obviously, my line was a little longer than it needed to be here, but these diagonals match, and what I wanted to end up with is here at the end up on top. So, ready to plug this into our calculator, which is going to tell us that 86,400 seconds is the answer. But this is one of the places where some people have some issues with sig figs. I know, it's weird. But if we're only sure that we're about 24 hours, not 24.0, not exactly 24 hours, but about 24 hours, then that's 2 sig figs. So I should only keep 2 sig figs in my final answer, which means I'm going to be rounding off that 4. The 4 is not going to change my 6 up, so it's going to stay a 6. And then when we're rounding off numbers where the decimal, even if it's invisible, is at the far end of the numbers we're rounding off. Basically, any numbers that we round off and remove between the sig figs we're keeping and that decimal point would need to get replaced with zeros. So 86,000 seconds is our final fully rounded answer here. And that's just because we needed it 2 sig figs. If that bothers you and you wanted to be sure of exactly how many seconds you were with more significance, then we'd have to take a better measurement of how many hours we're really dealing with here. So 24.0 would let us keep that 3rd sig fig in our answer. So without it, this is the best that we can approximate here. So this is where you need to join back in if you have already done 3, 4, and 5 on your own, because we are about to do number 6 together. And this is one that might look like it's pretty simple, and you probably know something about inches and feet that's going to help us turn this given inches squared into feet squared. But that's not quite the same. So most people, when they look at this, think, okay, well, like I said, I know something about inches and feet. 12 inches equals 1 foot. But that's not helpful to us here, or at least not all on its own, because while this is true, the units that we're trying to cancel here is square inches, or inches squared, and so those aren't going to be completely canceled by just normal old inches. So we have to cancel inches squared with inches squared. And it'd be kind of nice if all we had to do was square those inches and these feet, right? If that's all we had to do, it'd be easy. And while it's not all we have to do, it's almost all the way there. Just like most of the other stuff that we do with equations, if you square one side, you have to square the other. And in this case, if you square the units in an equation, you also need to square the numbers. But that's really it. 12 squared square inches is equal to 1 squared feet squared. Now, all of that kind of sounds a little bit weird to read out that way. So my recommendation, anytime you have to do this type of thing to an equation, square or cube, an equation that you already have, is do the math with any numbers. Change things into their final form, because the better this equation is written for you, the easier it's going to be to turn that into a conversion factor. So 12 squared is 144. Inches squared is just inches squared because it's just a unit. 1 squared is just 1. And then here's our feet squared. So now we have the units that we need for our given and our unknown in this red equation that's going to help us do the conversion we need here in one step. We just had to kind of get it ready to do that conversion. So we're going to start with the 1650 square inches. And then if I have inches squared here on top, then that means that I want to take this 144 inches squared and put that on bottom. 1 square foot can go on top. And that's as far as we needed to go. So 1650 divided by 144 is going to give us 11.4583, and lots more numbers are going to keep going after that. We don't need all of them, just need enough to make the decision on how many to keep. And this is, once again, a 3 sig fig number. It's almost as if 3 sig figs is pretty popular. So I just want to keep these first 3 sig figs. The 5 will round the 4 up, so 11.5 feet squared is our final answer. Hopefully that's not too bad. These squared inches and squared feet can be really scary when you don't know any equations that deal with them. But start from a simple equation, whatever you do know about normal inches and feet. And then just remember, whatever you do to those units, square them, cube them, raise them to whatever power you want, just make sure you do the same thing to the numbers that go with them. And that equation will still be true and can still be used as a conversion factor. Number 7 is also kind of simply complicated. It's got something special going on here with this given and its units, but it's not really that hard to deal with once you understand what's going on with the units. So in number 7, it asks us to calculate the miles per gallon of a car in Europe. So we're trying to find the fuel efficiency in miles per gallon of a car that currently is in Europe, and they don't use miles or gallons. So right now, what we know is that it's 10 kilometers per liter of gasoline. And we've got 2 equations already written out for you. Great. Now, the one thing that I really should have done or will do in the future in your packet and on tests and quizzes is actually write these units out in a slightly different form. That is still 10.0. But when I say kilometers per liter, technically the right way to write those symbols and kind of the shortened form of those units is km/L. That's what it means, kilometers per liter. It's just the condensed way of writing those combined units. Because the units on this 10 isn't just kilometers or liters, it's both. That's how we measure fuel efficiency. How far can I go on how much gas? So we're trying to turn those kilometers per liter into miles per gallon. So we're going to end up with miles per gallon at the end on our answer. Those are the units that we'll write on there. And this honestly is all I need to tell you to help you figure out or understand what's going to be going different in this. Because it's not the conversions that are weird. It's really this given. Because we have these weird units that have this line going through them, when we write this given with these combined units with the line going through them on our dimensional analysis line, we need to make sure that that line goes between them as well, so that they are not in the same bracket. They're in the same vertical space, but one of these is on top of the line, our kilometers, and the liters is underneath them. Because even though they're combined together with that value, we can't convert both of them at the same time. We can't cancel both of them out at the same time, so they shouldn't be in the same space. So the line separates the top from the bottom, even if it looks kind of left to right. km/liters is km over liters. And that's all we really need to do that's different. At this point, we're going to be trying to turn our kilometers into miles, and we're going to try and turn our liters into gallons. So we're kind of going to be doing 2 parallel conversions at different times, but on the same dimensional analysis bracket, so that we're going to get those combined units out that we need. So for right now, don't scratch it out, but kind of ignore the liters down here. Let's just focus on turning our kilometers into miles. And hopefully that's pretty obvious how we're going to do that with this green equation here. If I have kilometers on top of this bracket, well then I need to put kilometers on the bottom of that next bracket to cancel them out, which means that 1 mile is going on the top. I've got my diagonal rule all nice and aligned here. Kilometers and kilometers cancel, and what I'm left with on top is miles, and that is what I want on top of my final answer. So we've made progress. That's a good first step. But now that I've got those miles on top, I don't want to mess with them. So even though we are going to keep going forward, what we're doing now, even though it's a little spaced out from it, is going to help us cancel out our liters and get our gallons. So it's kind of from a distance, but we're going to be trying to cancel out these liters by filling in that red equation into this space for its conversion factor. And what you need to think about is if I have my liters here on the bottom of this dimensional analysis bracket here at the start, where should I be putting liters in this next conversion factor in order to cancel out liters if they're starting on bottom? And hopefully what you're realizing is, well, I'd have to put liters on top. Opposite side is always what we're going to be using to cancel with, like what we wrote up top. And generally, opposite side is the bottom. Every problem except for this one, opposite side has always been the bottom. But only when we have these combined units, where we have one of our units hiding down here below that given space, is when we start canceling by putting things on top. So in my red equation, the number that goes with that liters is 3.77. And then keeping our conversion factor together, that 1 gallon will go on the bottom. So liters is canceling with liters. And so what I'm left with is miles over gallons, just like I was looking for. So even though this seems like two completely separate conversions we were doing with the distance and the volume measurements, since it's all together, all on one line, all we should have to do is take our numbers, 10 times 1 times 3.77, then divided by 1.61 and divided by 1. And that should get us 23.4 and some other digits that aren't important, miles per gallon. That is our final answer here. So it's a simple conversion once you know to do each unit conversion separately. And that's all that there is to it. So I know that this video was kind of long. I hope that you did it in some pieces and some chunks that made sense to you. But if this was just too much, even if you got everything filled in on this page, please come in and ask, why did this go here? Why did you write this? What did this mean? How did you get this answer? How do I use my calculator? I would be more happy if you came in with 1,000 questions than if you came in with a blank page as a blank slate, ready for me to fill you up. But this is a process. It really helps to get the basics on. So thank you for watching the video, taking the time to try your best on it, and come to me with tutorials or in class, whatever you can, and let me help you get it the rest of the way there so that you're comfortable with it. Because like I said, we're going to be doing this stuff all the way through May. So we need to get it good so that you can relax and kind of understand what we're doing all the way through May. If you're struggling with it and you don't commit to learning it now, it's going to get shoved in there eventually, and it's going to be a painful process until we do. So let me know how I can help. Have a great rest of your night.